this video, we are going to discuss about the industrial IoT applications. So we know that the IoT plays a vital role in real-time application. So in this, the IIoT also plays a major role in every applications. So Industrial Internet of Things or IIoT is transforming manufacturing, energy, transportation and several other industrial sectors across the world. So let's recall the last class topic. In last class we discussed about the edge and fog computing, cloud computing in IoT. In this we discussed cloud computing, edge computing in detail and grid integration and the key comparison aspects of cloud, edge and grid integration. And today's topic for discussion is transforming and manufacturing beyond the IIoT in industrial applications. So in that, what is industrial IoT and key components of industrial IoT, manufacturing applications, energy sector use cases in IIoT, transportation and logistics, benefits realized across industries, implementation challenges and real-world success stories of IIoT. Now let's move on to the industrial IoT, transforming manufacturing and beyond the industries. So industrial IoT is revolutionizing traditional industries across India and around the globe. It is enabling new levels of productivity, efficiency, safety and innovation. From remote monitoring and predictive maintenance to smart grids and automated logistics, IIoT is reshaping how industries operate. This technological shift is creating unprecedented opportunities for growth, digital transformation and data-driven decision making. Now we are going to define what is industrial IoT from the DT empathize stage. To understand the IIoT, let us compare the traditional industrial systems with the IIoT enabled systems. Now we see about the traditional industry systems. The traditional factories depends heavily on isolated equipment, manual inspections and reactive maintenance. So the equipment failures are unpredictable and the decision making was very slow one. But in contrast with IIoT connects machines, sensors, controllers and cloud platforms into an intelligent network. These connected devices continuously gather, analyze and share the data. This enables automated monitoring, predictive insights and real-time optimization of industrial operations. So the result, industry shift from reactive to proactive management. So now we see about the defining stage of the DT, that is the key components of industrial IoT applications. The IIoT systems typically include four major components. The first one is sensors and actuators. These capture real-time data such as temperature, vibration, pressure and speed. The connectivity networks, technological like Ethernet, Wi-Fi, 5G, LoRaWAN and industrial fiberless ensures reliable communication. So edge and cloud computing. The edge devices process data locally while cloud platforms store, analyze and visualize the large data. So if we come to industrial applications, these include dashboards, analytics platforms, SCADA systems and AI-driven decision tools. Together, these components enable efficient, intelligent industrial automation. So manufacturing applications of IIoT. The manufacturing remains the biggest beneficiary of IIoT. Two major use cases include, one is a predictive maintenance and another one is a quality control. Let's see the predictive maintenance. The IIoT sensors continuously monitor equipment performance by detecting anomalies early, such as abnormal vibrations or temperature rise, maintenance, and it can be scheduled before a breakdown occurs. This avoids costly unplanned downtime and extends machine lifespan. Next one is a quality control. The real-time monitoring of production parameters ensures consistent quality. Any deviation from standards is automatically detected, allowing faster corrective actions. Leading manufacturers worldwide report a 30 to 50% reduction in unplanned downtime and up to 20% improvement in product quality due to IIoT adoption. Now let's move on to the energy sector use cases. In the energy domain, IIoT plays a critical role in smart grid automation, real-time energy consumption monitoring, renewable energy management, predictive maintenance of transformers, turbines and distribution systems, and remote monitoring of solar and wind farms. So this leads to a reduced losses, optimized energy distribution and enhanced system reliability. So the energy sector reduces unwanted losses and improves the energy efficiency. The transportation and logistics IIoT enhances transportation and supply chain operations through fleet tracking and route optimization, real-time cargo monitoring, intelligent traffic management and warehouse automation. With IoT-enabled tracking, industries achieves smoother logistic operations, reduced fuel consumption and improved delivery efficiency. And the benefits of realized across industries. Across various sectors, IIoT delivers measured benefits such as reduced operational cost, lower consumption and cost savings, higher productivity, improved worker safety, enhanced product quality and data-driven decision making. So organizations implementing IIoT experiences significant improvements in performance and reliability. Next one is the implementation and challenges of IIoT. So the implementation and challenges in IIoT, however, the common issues includes cybersecurity risk due to increased connectivity and integration difficulties with legacy systems, high initial investment cost, the need for skilled professionals and ensuring reliable network infrastructure. Addressing these challenges is essential to ensure a secure and scalable IIoT deployment. Let's move on to the IIoT application includes a cloud service, database, IoT-based smart industry, smart transport and logistics. So the data are stored in the cloud and we can get the analyzed and visualized data. Let's move on to the summary part of industrial IoT applications. In summary, IIoT is revolutionizing modern industries and enabling next generation automation. It is also transforming healthcare under the broader concept of the Internet of Medical Things, where connected medical devices ensure better diagnosis and patient care. Successful IIoT solutions require rigorous designing, secure architectures, well-planned prototyping, and continuous testing. With the right approach, IIoT can unlock massive value for industries across the globe. Now let's test our IQ. Which of the following best describes the main goal of the industrial Internet of Things? The answer is to connect industrial machines and enable data-driven automation. In IIoT system, which component is primarily responsible for collecting real-time data from machinery and equipment? The answer is sensor. These are all the references for this presentation. Thank you.